Did everybody attend Dr. Paul Vixie's talk this morning? Was that awesome or what? So one of the things that he talked about there was war domains, the domains of war. And he talked about the fact that IT is now one of those domains. And so that's kind of what I'm going to start this talk off with, is my incident response horror story. Right? This was one of the times when I actually went into combat against an adversary. So I want you to kind of close your eyes and put yourself in my shoes. This happened many, many years ago. So imagine you show up at work and you sit down at your desk. You've got your caffeinated beverage in one hand. You've got your mouse in the other hand. And your job is to defend this enterprise. You're part of a 2-man security team for a 3,000-person company with offices all around the world and literally thousands of public-facing websites, right? Can you feel the challenge? Do you feel the pain? So that's challenge number 1. Challenge number 2 is you are working for a dying newspaper company in a dying newspaper industry, because who actually buys a newspaper anymore, right? So budget is limited. So you have some commercial tools, but not a whole lot. And for those limited commercial tools that you have, you really don't have them fully deployed across your enterprise, right? So you have limited visibility into what's happening on your network, what's happening on your endpoints, etc. So with that kind of context, with that kind of scope in mind, you sit down, you start looking at your limited commercial IDS appliance, and you start looking through Ids Alerts. You've got an interesting alert here for SQL injection, a SQL injection attempt against one of your public-facing websites. Now, if you're in this role and you're monitoring literally thousands of public-facing websites, you sort of understand that there's a normal amount of background radiation on the internet, right? There's this normal amount of scanning activity where certain IP addresses are going to scan the entire internet every single day. And that happens quite often, and that's absolutely normal, right? So you build this mental baseline of what's normal for those network segments that you're monitoring, and anything above that is kind of abnormal, and that's when you start the investigative process. So on this Monday, you come into work, you do your normal routine of looking at your alerts, you see your SQL injection attempts that you expect, but you see a higher number of those SQL injection attempts. You see that they are more targeted at specific public-facing websites. You see that they're a little bit more persistent. They're a little bit more loud. So that's really the starting point for this investigation, to say, okay, well, this is a little bit more than I'm comfortable with. It's one of those moments where the hair on the back of your neck kind of stands up a little bit. You feel that ever? So you start the investigative process, and you start trying to pull together the pieces of the puzzle. Now, again, this is where things are difficult because we have limited commercial tooling, we have limited visibility, so we're pulling together little bits and pieces here and there. So we're tracking this activity as the week goes on. Tuesday, Wednesday, Thursday, Friday. These SQL injection attempts continue throughout the week, and they continue to escalate. Now, one thing that you notice as you're monitoring this activity, as you're investigating these alerts, you notice the user agent string as you look at the actual HTTP requests, and you see that that user agent string actually matches up with what was then called Backtrack Linux, now called Kali Linux, right? That's the attacker's tool set, all in a nice, convenient Linux distribution, ISO image, easy to download, easy to fire up, easy to point and go and attack a website. So that's certainly interesting. Another thing that you see is the IP address that these attacks are coming from, right? All of these attacks all coming from the same IP address. So now as these things go throughout the week and Friday finally rolls around, it's Friday afternoon, you want to go home, you want to spend time with your family and friends, you don't want to sit at the office all weekend monitoring these attacks. So you have to make a decision, as we, this 2-man security team, had to make a decision. Do you allow these attacks to continue throughout the weekend, or do you block the attacker's IP address in the firewall? What do you do? I hear block it. Who else says block it? That's probably a majority. So that's what we did. We decided to block the attacker's IP address in our firewall. So what do you think happened next? IP address change, right? So the attack stopped from the one IP address, but they started up from another IP address, and actually another IP address, and actually a third other IP address. All right, so what had we done? We had simply kicked the hornet's nest, right? We tipped off the attacker that we were onto them, right? We've now escalated that arms race. So the attacks continued throughout the weekend. Sunday night, about 10 p.m., one of these SQL injection attempts finally succeeded. The attacker popped the box. They were in on one of our public-facing web servers. Now, this is where things get even more difficult because that segment of the network, we had some visibility. But as soon as they get into that box, there's an internal network there where we had very little visibility. I see some shaking of heads. You've been there, done that. You've felt that pain, right? So now we have to, number one, go to management and say, hey, you know that incident that we kind of briefed you about last week? We kind of gave you the heads up that this was happening. Well, Sunday night, 10 p.m., he broke in. So we now need to take that box offline. What do you think management said? No, thou shalt not take that box offline. We're a dying newspaper company in a dying newspaper industry. That box is making us money. Thou shalt not take it offline, right? So now you've got to try to fight the attacker off the box. Easier said than done in many cases, right? So, trying to do that, trying to continue to collect evidence, trying to continue to put these pieces of the puzzle together, all the while also looping in our local FBI field agents to start to build a case against whoever this adversary is. And, you know, it's great to have a relationship with your local FBI field agent if you don't already, because in that heat of the moment, right, when you're in incident response mode, you don't want to have to be reaching out for the first time. You want to be able to call them up. They already know who you are, who you work for, and what the context of this incident might be. So FBI is great. Make sure you have contact with your local agent. But keep in mind the FBI, they have process that they have to work through. Right? You tell them that here's an IP address that's attacking me. They have to go through warrants and subpoenas. They have to talk to judges, and this process takes time, right? So we're continuing to try to fight the attacker off the box, continuing to collect evidence, waiting for the FBI, and at the same time, since we're waiting on the FBI, well, let's see if we can kind of work this case ourselves. Let's do some open source intelligence research on this IP address. And as it turns out, we figured out who the guy was who owned that IP address. So we can now put a name and a face with this IP address. We knew who it was. So you continue to do more research, and you find out where this gentleman lives, right? So we figured out where he lives. Do we go and talk to him? Do we knock on his door? Do we approach him? What do you do? The other thing that we found out, and this is where the story really takes a strange turn, we found out that this particular individual was terminally ill. Right? So here's an individual who literally has nothing to lose. Right? So this story, there's a lot of details that I'm having to gloss over here due to time. It normally takes about an hour to tell this entire story. But the short version of it is that as we were continuing to wait on the FBI to go through warrants and subpoenas to get the proper address and go approach the individual, he literally passed away before the FBI could knock on his door and interrogate this individual. So what we're talking about is the fact that we had this insanely difficult task in front of us to try to collect all of this information and try to piece together the puzzle in a limited time frame, right? We literally couldn't do it before time ran out for this particular investigation. So that was a difficult incident response time. But it really kind of underscored to me some lessons learned. The first of which is that incident response is going to be slow and difficult if you don't already have the right data sitting at your fingertips, right? I talked about having to collect Ids Alerts from this appliance over here, and we had some other limited tooling over here, and then maybe we went to our system engineers and requested some syslog, but maybe this syslog was in this time zone, and this syslog was in this time zone, and maybe there was some skew between them, so correlation becomes a nightmare. So that process is going to be cumbersome, right? When you're in the heat of battle and you're trying to correlate timestamps and are not quite lining up, it makes it even more difficult than it already is. We talked before about how we had limited visibility because the traditional security tools at that moment in time were prohibitively expensive, right? And if you look at the commercial market today, they're still very, very expensive. And for many organizations that choose to invest in commercial security appliances, they may have to pick and choose based on their limited budget. I'm going to have visibility here, but I simply can't afford to have visibility over here. And that is fundamentally unjust. Just like it's fundamentally unjust that this attacker was able to use Backtrack Linux and have all of his favorite attack tools already compiled, already configured, and at the time, we as defenders did not have the equivalent from a blue team defender perspective. That's fundamentally unjust. And so that's really where Security Onion comes into play. I started this project in 2008 to provide a free and open source platform for the things that we do as defenders. That's intrusion detection, network security monitoring, threat hunting, incident response, all of that good stuff, right? Just like in the world of Linux, which I've been involved with since 1997, you know, back in the day, folks were compiling every single thing on their own boxes. Some folks still do it today, but most of us use Linux distributions, right? Where everything's already compiled, already packaged for you. And that's where we needed to get as defenders, was I saw a lot of folks that they might download the Snort tarball, they might download the Bro tarball, they might compile these components, they might get them working, but it might take days, weeks, or sometimes months to get all of this tooling up and running before they could ever do their real job of defending their networks. So finally, the thing that we all realize is that as time has gone on, more and more of our network traffic is now encrypted. So that becomes somewhat of a blind spot in terms of our network visibility. So we want to fill in those blind spots with endpoint visibility. We'll talk more about that in just a few minutes. So I started the free and open source platform in 2008. In 2014, I started Security Onion Solutions. That's the company behind that free and open source platform. Everybody always wants to know, well, how do you make money off of free and open source software? Our business model is that we provide on-site training and online training. We do professional services, and we also sell hardware appliances preloaded with our software. But our free and open source platform remains free today. You can go and download it. It's been downloaded over 950,000 times. And that's just one of our download methods. Most folks will use our ISO image. It's based on Ubuntu. It's got all of the software already installed, ready to go out of the box. If you prefer not to use our ISO image, you can install your preferred flavor of Ubuntu and then add our packages on top of that. So that's entirely up to you. Now, that's our traditional platform. We're working on a next generation platform right now, which we call Hybrid Hunter. And it's got some major architectural changes, one of which is because a lot of our customers are military and they prefer Red Hat CentOS to Ubuntu. We wanted to give them an ability to be able to run Security Onion on their favorite platform. And one of the things that we've been doing over the last few years is investing in the container ecosystem, right? So what we're now doing with our next generation platform is moving from our traditional Ubuntu packages, now putting everything into Docker containers. Makes it that much easier to run on different Linux distributions. So out of the box, we're going to support Ubuntu and Red Hat and CentOS. So you can download Hybrid Hunter today. It's currently in testing. So you can test that out. You can give us feedback, and we hope to finalize that, release a final version later this year. Now, that's just a brief overview of Hybrid Hunter. For the rest of this presentation, I'm going to be focusing on our traditional platform. And so let's kind of zoom in and take a deeper look at what that platform actually looks like. I mentioned before things like Ids Alerts. I started off my war story this morning with Ids Alerts. And I include this picture here of this iceberg because that's really what Ids Alerts represent, is really kind of the proverbial tip of the iceberg, right? Because if you've ever looked at a network-based IDS and you've looked at Ids Alerts before, you realize that they're really just a question. They may or may not provide the answer to that question. Most of the time, it's up to us as the defenders, as the analysts, to investigate and then answer that question. So we start off with Ids Alerts. We give you the choice of Snort or Suricata. Both of those have been around for a long time. They work really well. They monitor your network traffic coming off of a tap or a span port. They look for signs of suspicious activity, and they generate those network-based Ids Alerts. So once you have those Ids Alerts, now it's time to investigate them. Figure out, is this a true positive or a false positive? If it's a true positive, do I care about it? Does it even apply to my environment? Do I need to investigate it? Did something happen after the fact? And that's where the protocol metadata comes into play. Now, previously, we used a tool called Bro. It's now been renamed to Zeek, so you may hear it used using either one of those two terms interchangeably. But it provides this rich protocol metadata, which allows us to really paint a more complete picture around those Ids Alerts, right? Because if I have an Ids alert, I might say, well, if this machine is compromised, what happened next? Did it then beacon out to a command and control server? Did it do some data exfiltration? Was there some pivoting laterally throughout my environment? My protocol metadata coming from Zeek can help me to determine that, right? I can look at my session data. That shows me all of my connections from this IP address to this IP address. I can look at DNS lookups. I can look at HTTP transactions. I can look at SSL certificates. All of that is lovely protocol metadata that we're assembling for you, collecting into the same spot so that we can then investigate those Ids Alerts. Now, once we start going deeper underneath the water of that iceberg, we may get to a point where we feel like this is really an incident. We really need to investigate what happened here. We might then need to kind of rewind the videotape, right? If you think about physical security, you've got a security camera that's recording everything. You then might want to rewind that videotape and reconstruct the scene of the crime. That's what we do with full packet capture. We use a tool called NetSniffNG for that, and that's recording every single packet that crosses your network all the time, so that we can rewind that videotape and we can actually look at that TCP stream from start to finish. We'll actually see that in a few minutes in the demo. But using all of those different kinds of data together, we can paint a more complete picture about what actually happened. We can see how the adversary got in, we can see what happened after they established that foothold, and we can see ultimately how they tried to achieve their objectives, or perhaps did achieve their objectives. So that's kind of our data types from a network perspective. Once you have those different components running, monitoring your network traffic coming from a tap or a span port, and you're now generating network-based Ids alerts, you're now generating Zeek logs, you need a place to store all of that data, right? So we include the Elastic Stack that consists of Elasticsearch, Logstash, and Kibana. So we're going to take all the logs, consume them with Logstash, which is then going to store them in Elasticsearch, and then we're going to use Kibana as our web interface to slice and dice all of those logs, right? So when you log into our Kibana instance that's included by default in Security Onion, we have a bunch of dashboards right out of the box. Over 30 dashboards, one for each particular protocol that you may expect to see on your network, and some for host-based data as well. And that makes it easy because we've already built these dashboards with all the visualizations that help you to look for those anomalies on your network, right? Because kind of what we've seen as an industry is that many times IDS alerts are a good starting place for our investigations, but what happens if you have an adversary that's sophisticated enough to evade your IDS signatures? You may not have any alerts whatsoever, right? So at that point, we may need to do some threat hunting, right? And that's where all of our Zeek logs and all of our dashboards really help us to take this massive amount of data and do an aggregation based on a particular field and look for outliers, right? We look for typical user agent strings. We exclude those, and then whatever's left over, those are interesting user agents that I might want to investigate. Just an example of how we might do some very simple user agent threat hunting. Now, I mentioned before network-based data and the fact that more and more of our network traffic is becoming encrypted. That's a good thing for privacy. However, it makes our lives as defenders a little bit more difficult. So we want to fill in those blind spots with some additional endpoint telemetry, right? So we integrate with Wazoo, which is a host-based intrusion detection system. It's based on an older piece of software called OSEC, which you may have heard of by that name. And as a host-based intrusion detection system, it gives you a lot of bang for the buck. This is a cross-platform, free and open source endpoint agent, which gives you log collection, log analysis, file integrity checking, and rootkit detection, right? So that's a lot of capability built into one free and open source agent. Now, in addition, because we have the Elastic Stack, we also integrate well with the Elastic suite of endpoint agents. So that's the beats family. So you have WinLogBeat, you have FileBeat, etc. So those integrate quite nicely. Now, if you're in a Windows environment, and most folks are, chances are you have a large percentage of Windows endpoints in your environment. If you're familiar with Mark Russinovich and the sysinternals team at Microsoft, they create some great utilities, namely Sysmon and auto runs, which give you some really great visibility from your Windows endpoints in terms of what's actually happening on those boxes, right? And this goes above and beyond just the standard default Windows logging, gives you some extra comprehensive stuff, especially in terms of what processes are executing on your Windows endpoints. And what are those processes actually doing in terms of network traffic? So again, even if your network traffic is encrypted, if you can get that viewpoint from the endpoint itself, right, that's going to give you some additional visibility that you might not have been able to see just from a tap or a span port perspective. And then finally, OS Query is another great cross-platform utility for interrogating your endpoints, very helpful in terms of incident response and being able to see what's happening kind of across your fleet. Here's a very quick screenshot of, I mentioned in the previous slide, Sysmon. And so let's say you have a Windows endpoint. You've got Sysmon installed, so it's giving you really great comprehensive intelligence about the processes that are running on your Windows box. You could then have those Sysmon logs being transported to Security Onion by way of Wazoo, and then Wazoo on the Security Onion server side is going to analyze all those logs, and it's going to look for suspicious processes running on your Windows endpoints, right? That's very powerful visibility to have, especially with more and more of our network traffic being encrypted. And this is just a quick screenshot of our Sysmon dashboard just to give you an example of some of the things that you can see just by installing Sysmon and having that endpoint visibility. So even if you don't have any network visibility, you can still see things like this Windows endpoint connecting out to Amazon, for example. So that's a very brief overview of our architecture and the kind of data types that we provide to you in terms of threat hunting and incident response. Let's talk about some use cases. So if this is your first time hearing about Security Onion today, you can go home and you can download our ISO image, you can install it in a virtual machine, and you can be up and running very quickly in what we kind of call this small forensics VM use case. Right, so the quickest and easiest way to get up and running with Security Onion is a tool that we have called Esso import Pcap. So if you have a Pcap file from your existing network, you can import that Pcap. If you don't already have any existing Pcaps, we have some built right in, right? So we'll look at that in just a few minutes in our live demo, where we'll use Esso import Pcap. We'll import one of the Pcap files that we have built right into our ISO image, and we'll actually work a real case based on importing that Pcap. So that's very quick, very easy. It's a good way to get your feet wet with Security Onion and kind of understand all the different data types, how they relate to each other, and how you put together all that information to work an incident. Now, once you've done that and you've kind of gotten some experience with Security Onion and these different data types and how to use them to monitor and defend your network, you might want to go to the next step, which is, okay, I'm ready to stand up a real production deployment of Security Onion on my network. So maybe you have some budget for a brand new server that you're going to deploy on, but maybe you don't. Maybe you have to take an old decommissioned server that was retired a couple of years ago, and that's fine too. Take whatever server hardware you have, install Security Onion on it, connect it to a TAP or a span port to give you that initial network visibility. And probably the first place that you're going to start there is your network perimeter, right? That place where your internal network meets the big bad internet. That's where you're going to start your monitoring activities in terms of Security Onion. So that's kind of that north-south network traffic that we're talking about going out to the internet and coming back. So once you've kind of demonstrated some success there, and quite often what we see with folks is they'll do that and they'll have a very quick win, right? Where they find something that they never saw before on their networks. And that might be a total compromised workstation, or that might be simply a misconfiguration. But they demonstrate a quick win to management, and they go back to management and they say, hey, look what I found using this free software and this recycled hardware. Imagine what I could do if I had some budget, right? We've seen lots of folks use that as a strategy to be able to work through this and be able to build a much larger deployment just based on demonstrating a quick win, going back to management and getting more budget. So once you're able to build a larger deployment, right, your existing single standalone Security Onion box can become kind of a master server for this new deployment. And you're now then adding additional sensor nodes that are going to connect into that sensor grid. And you can also kind of scale up your backend storage, that Elasticsearch backend that we talked about, by adding additional storage nodes, right? So we can start with a single standalone box, and we can kind of scale that in both directions. Add additional sensors, add additional backend storage nodes, and you've now got this enterprise-wide deployment that contrasts that with how I kind of started off the talk today, which was commercial tools may be cost prohibitive, right? They may prevent you from getting the full visibility that you need to defend your environment. But with free and open source software, you can deploy this as many times as you need to as many boxes as you need to, collecting as many millions or billions of logs as you need to monitor and defend your enterprise. Finally, I do want to mention, so far we've been talking primarily about on-prem deployments. But, of course, lots of folks are in the cloud these days, and so we do support that as well. So in addition to our kind of traditional ISO image that we have, we do also have an AMI. So if you're in Amazon, you can go and download our AMI, and it's good to go. All right, so how about a live demo? Would you like to see it? All right. So we're all going to be analysts in the Security Operations Center here, right? So go back to how we started off the morning. You know, you roll into work one day, you've got your caffeinated beverage in one hand, you've got your mouse in the other hand, and now it's our job as the Security Operations Center to monitor and defend our enterprise. So what I've done here is I've installed Security Onion in a virtual machine, and I used that very first use case that we talked about, and that's Esso import Pcap. So all I've done here is I've taken an existing Pcap file that we include right in our distro. So you could actually duplicate this at home today, Go and download our ISO image, run Esso import Pcap, and pass it the full path to this Pcap file, and you could actually do this step by step, exactly what we're doing today. So the Pcap file that I imported is a very small Pcap, not a whole lot of traffic. You can see here that there's only 36 logs, but there's actually some quite interesting stuff as we look through here. And as we go through and look at these different data types, I want you to keep in mind kind of what I said before about the way it was back in the day when I started all this, when we just had a traditional commercial IDS appliance. We had limited IDS alerts and limited investigative capability. And so there'll come a point in this demo where, from a traditional IDS perspective, we would have had to stop that investigation because we wouldn't have had any more visibility. And we'll talk about that as we go along. So this, of course, is Kibana. That's our web front end for slicing and dicing all of our logs that are inside of Elasticsearch. And I mentioned before that we do include lots and lots of dashboards. You can see that entire list here. That's over 30 different dashboards. And so, for example, if you just look at Zeek hunting, these are our dashboards designed for doing threat hunting in these Zeek logs. Again, Zeek is providing that protocol metadata for our network. So we have a dashboard that shows all the connections on our network. We have a dashboard that shows all the DNS lookups on our network, HTTP transactions, SSL certificates, so on and so forth. So lots of default dashboards right out of the box, so you don't have to build anything, you don't have to design anything, you simply have to install it and go. So now, having said that, let's kind of look at, based on the fact that we had, 36 logs, those logs are broken down into two different types. So let's see what kind of types of logs we have. Well, the first we have is IDS alerts. I mentioned before IDS alerts coming from Snort or Suricata. So we've got our network-based IDS alerts. We've got 14 of them here. And so remember that picture of the iceberg that I showed before, right? IDS alerts may be simply the tip of the iceberg. So we want to keep that in mind when we take a look at those IDS alerts. So what I'm going to do here is I'm going to scroll down my dashboard because I do have a visualization down here that shows those IDS alerts in a little bit more detail. All right, so this is where I'm going to ask for some audience participation. So looking at this list of IDS alerts, you see the name of the IDS alert on the left. Do you see any particular IDS alert there that stands out to you, that seems more interesting? So they're all pretty much relating to an executable. I heard somebody say .doc.exe. So what's interesting about that? Right, so there's a couple of points there, right? Because number one, modern versions of Windows by default are going to hide file extensions, all right? So if you were to think about this in the case of a spear phishing email, which is one of the most prevalent attack vectors that we have today. Let's say I'm an adversary and I want to break into your environment. I know that I can get in via spear phishing email. So I'm going to find one of your employees and I'm going to send them an email that says, hey, this is the HR department and I need you to download this Word document for the new payroll system, right? Everybody wants to get paid, so I'm going to download that Word document. And even if I look at it in Windows Explorer, it's going to hide that file extension, and it's going to show me .doc, so I'm going to think, yep, that's a harmless Word document, right? So that's definitely interesting to me, and that's definitely something that we see in spear phishing attacks. So let's take a look at that. So I can click on this magnifying glass here to filter my entire dashboard based on that one IDS alert. And if I wanted to, I could drill into the log itself and I could see all the individual fields in the log. But one of the things I talked about before was full packet capture and being able to rewind that videotape and reconstruct the scene of the crime. So what we can do here is we can click on this hyperlink that we have, which is going to give us that full packet capture, right? So we just rewound the videotape and we're now looking at that TCP stream in its entirety. Now, I mentioned before traditional IDS appliances which might have generated this IDS alert, and they might have given us a little bit of packet data. So they might have shown us this up here, but they probably wouldn't shown all of the rest of the stuff that comes after that. And we'll talk through what that is and the importance of it in just a minute. But let's kind of focus just for a minute on kind of looking at this HTTP traffic and figuring out what it's telling us. First of all, we see that there is an HTTP GET request for this swingmechanics.doc.exe. So that's why that IDS alert fired. So we immediately have kind of confirmation that this is a true positive. We're dealing with a real IDS alert here. And the next thing that we see, if we look at our HTTP host header, we see the fact that this is a bare IP address. Right? Normally, I expect most of my traffic would be going to a fully qualified domain name, right? A real website like Microsoft.com. And especially in the case of a Windows exe, if that's a legitimate exe, let's say a Windows update, I would expect that to come from something like update.microsoft.com. But in this case, I see somebody downloading an executable from a bare IP address. That's not 100% malicious, but it's definitely suspicious, right? So that's interesting. The other thing that's interesting here is not something that we see, but it's something that we don't see. So there's a header here that is missing, and that's the referrer field. So if you look at the HTTP referrer field, it tells you what website you came from. So if I'm on one website and I click a link which takes me to another website, the header would say, referrer, that original website we were on. But we don't see that referrer field here. What that tells me is that we weren't on another website when we went here. So I might infer that if this were a spear phishing email, right, and I get that email in my traditional email client, let's say Microsoft Outlook, I click the link, it spawns my web browser, and it looks just like this, right? Because I didn't come from another website, I came from another program altogether, right? So that continues to kind of fit into this model of perhaps we're dealing with a spear phishing email. Now, as I said before, traditional IDS alert appliances may provide some packet data, maybe this up here, but they might not provide the rest of the TCP stream. But that's where things really get interesting. So we can see in this case, the web server responds with a 200 OK. We can see the MZ file header. So that kind of verifies that, yeah, this is actually a Windows exe. We see some DLL references. And as we go through here, because this is full packet capture, number one, I could download this as a Pcap. I could actually extract that exe out. I could do reverse engineering on it if I wanted to. But even without going to those links, there's a whole lot of intelligence to be gleaned just by looking at this stream in its existing clear text. So if I scroll in here, I see this. Can anybody tell me what that might be referring to? I hear command and control server, and we'll get to that in a minute. So what we're seeing here is the HTTP connect verb or connect method. So if you go and read the HTTP RFC, this is actually a method by which a browser can connect through a proxy server, right? So if we're talking about malware, then this would be considered proxy-aware malware, right? So that's definitely interesting. HTTP version 1.0, yeah, there's a lot of interesting things that you can pick up once you start looking at this traffic, right? So let's scroll a little bit further and see if there's anything else that might be interesting. Does anybody see anything interesting here? I hear a registry entry. All right, so what is this? It's a registry entry, and it's the run key, which in terms of malware, we would consider to be a persistence mechanism. Why? Because when your Windows machine boots up, it's going to reference this run key, and anything that's listed there, it's going to run that process. That means that as an adversary, right, I can get you to run this process once by clicking on the download in the email, But normally, the second you turn your machine off, that process is gone. But now the next time you turn it on, it's going to reference this run key. It's going to start my process all over again. So that's a persistence mechanism, right? So again, in the case of malware, we're looking at something that's proxy aware. We're looking at something with a persistence mechanism. Anybody see anything else interesting here? I see service hosts. Very good. Anything else? I heard somebody say it. There's an IP address there. That's interesting. The plot thickens, right? So what might that IP address be? The mothership, right? The command and control server, the C2 server, right? So when I'm working cases like this, I'm going to ask myself a series of questions. So in the case of an IDS alert that's about a user downloading an exe, I'm going to ask the question, number one, did they actually request the exe? We've already seen evidence that yes, they did the HTTP GET request, so yes, it's coming down to their PC. Number two, did they actually execute that exe? So if it actually landed on their machine, did it get quarantined by antivirus or some other kind of endpoint agent, or did it actually land, and were they able to detonate that exe in their environment? So to answer that question, if I see a hard-coded IP address like this, I might expect to see connections to that IP address. So that's where our other data types come into play, right? Because our IDS alerts really kind of tipped us off just to this point right here. But the rest of our data, like the protocol metadata that we talked about before, is going to answer this question of, were there any connections to this 221 IP address? So let's take a step back and let's see if we can answer that question. So let's clear this filter. And what we'll do next is, if you remember, we talked about Zeek, which was formerly known as Bro, gives us this rich metadata about what's happening on our network. And specifically, these Bro con logs are the connection logs. This is what we would call session data. It shows that this IP address connected to this IP address on this port for this many bytes and this many packets. So I could click on the magnifying glass, filter the entire dashboard to only show me those connections. And there's not many connections here because this is a rather small Pcap. But as I zoom in, does anybody see that IP address that we were looking for? Absolutely. So in this case, our victim IP address is 172.16.150.20, and we do indeed see a connection out to 221.54.197.32. The plot thickens, right? So what can we infer at this point? They actually executed the exe. It's active, right? Well, we'll talk about lateral movement in a minute. That's where things get interesting as well. So we see here a port of 443. So what does that make you think of? It makes us think of SSL, all right? So let's kind of test that assumption by pivoting to our full packet capture. All right, so we'll click on this hyperlink. We'll go and get our full TCP stream. All right, so let me ask the question. Is this SSL? It's encrypted because we can't read any good old-fashioned ASCII clear text. Can I blow it up? I can blow it up. Watch this. How much do you want me to blow it up? I can keep going. I heard base 64. Well, maybe. Here's the thing. If this were traditional, well-formed SSL traffic like we would expect to see on port 443, what has to happen first before the encryption can begin? There has to be a handshake. There has to be a certificate exchange. That certificate has to be transferred in clear text. Do we see that here? No, we actually don't. Normally, we would see in this very first part, you'd see the name of the website. You'd see those certificate fields like country, state, city. We're not seeing that here, and that's because this is not SSL. This is not TLS. This is malware with its own encryption mechanism. It just happens to ride over port 443 because, let's face it, it's open in every single firewall out to the internet. It has to be in most organizations. So what we're dealing with here is actually a piece of malware called Poison Ivy. It's a remote access Trojan. It has its own encryption mechanism. Now you could go out to the internet and you might be able to find a tool that can decrypt this. However, the adversary, if they're sophisticated enough, may have set their own key, or they may have changed that encryption in some other way. So you still may not be able to fully decrypt what's going on here. But because this is full packet capture, and because we can sort of see the difference between source and destination via color coding, you get to this point here where there's kind of this back and forth. So if you kind of squint your eyes and maybe make some guesses here, you might start to think that this looks like interactive behavior. This almost looks like an interactive shell. And as it turns out, this Poison Ivy remote access Trojan, it can allow that, right? An attacker, once they've compromised a victim machine with this remote access Trojan, they can then turn on an interactive shell. They can issue commands to that Windows machine. So just like you pop open cmd.exe, that attacker can do the same exact thing. And that's kind of what that looks like there because of that interactivity. So that's pretty interesting. Now, somebody before said something about lateral movement. And that's typically what you see in these kinds of cases where an attacker may start off with a spear phishing email, user clicks on the email, they compromise their machine, they're now a victim. That establishes the outbound command and control traffic to the C2 server. That adversary is now starting to issue commands to that victim machine, and their next step is to pivot laterally in the environment. Because now I want to go from that initial foothold to actually targeting towards my objectives, which might be going after your domain controllers, it might be going after your file servers, it might be going after your database servers, it might be going after your HR department, whatever their objectives may be. So now we want to kind of ask that question, what happened next? And we did see, in looking at these data types, that we see our old friend FTP. Now that's interesting, right? Could be used for legitimate things. It's standard file transfer protocol. But let's say that this particular user, they had no standard business need for FTP. So we might want to investigate that. So again, we'll click on the magnifying glass. We filter the dashboard. And if we scroll down to one of these FTP logs, we could then pivot to our full packet capture. All right, this is where things really start to get interesting. What's happening here is the adversary is issuing commands to this victim machine to log into the adversary's own FTP server. And you can see him logging in with a username of Jack and a password of 2. Awesome. All right, I like this guy. And then we see him using the FTP store command. And what the FTP store command does is an upload. It uploads a file to that adversary FTP server, and that file is called 1.txt. Then after that, there's another store command, and that's for 2.txt. So what we're seeing at this point is that the adversary has done some lateral movement. They've captured the keys to the kingdom, and they're now exfiltrating that to their own FTP server. Now it's our job to figure out what was that data. What was the data that walked out the door? All right, so to answer that question, we have to remember how good old-fashioned FTP works, because this TCP stream ends right here. We don't see those actual files. But if you remember the way that good old-fashioned FTP works, you have a control channel and a data channel. So now if I clear my filter, I could go back to my bro connection logs. And when I scroll down here, if we remember that FTP starts on port 21, that's what we were just looking at right there. But the data channel is actually on port 20, and that's the line above. That's this connection and this one up here. So let's again pivot to our full packet capture. And let's reconstruct the scene of the crime. What do we see here? What we're seeing is Jisuk Dump. Jisuk Dump is a utility used to dump Windows password hashes. Now, as an adversary, I'm interested in your password hashes. I might do one of two things with them. Number one, I might take those password hashes, exfiltrate them, bring them back to my environment, and put them into something like John the Ripper so I can crack those passwords, and now I've got your password. Or I might simply use the hashes directly in a pass the hash attack. Either way, those password hashes are very valuable to me as an adversary, and I'm absolutely going after them. So now if you look at this output, do we actually see Windows password hashes in this output? Well, we see some references to LSA secrets, but if you really kind of look at this closely, see, this is the cool part about full packet capture, and when you really start to zoom in and think about why things say the things that they say, this is the help output from the Jisuk Dump command. Well, so here's what I'm envisioning, right? Imagine your nice little adversary. He's issuing commands, and he's trying to do something like Jisuk Dump -a redirect into one.txt. That's what he meant to do. But maybe he was in a hurry, and maybe he fat-fingered it and did AA or something like that. And so Jisuk Dump says, no, you're an idiot. That's not a real option. Here's the real options, right? So it's kind of fun when you can watch adversaries screw up, because they're just human just like we are. We all make mistakes. So in this case, I'm not quite as concerned about this as I would have been if I saw real password hashes. But I'm still somewhat concerned because Jisuk Dump is not included in Windows. So the adversary probably put it there, and he was definitely able to execute it, even if he fat-fingered the options. So I'm still somewhat concerned, but oh wait. There was another file, right? Now we need to go back and look at that other file. So let's pivot to this other one. So what is this? This is a Rar file. What's a Rar file? It's an archive file. It's like a zip file, right? So what's inside of this archive file? Can anybody tell just by looking at this? So, as it turns out, this is actually a password-protected Rar file, right? So just from looking at it from this perspective, we're not going to be able to tell what files are inside of it. But keep in mind, this is full packet capture. So we can download this Pcap. We can open it up in our good old friend Wireshark. And we can then extract the file right out of that network traffic. So if I right-click and follow TCP stream, I can now save this as raw data, and I'll call this out.rar. So now if I go to my downloads folder, here's my out.rar. Password required. Now, I want to kind of rewind to something I said a few minutes ago. I was talking about password hashes, and I said an attacker might take our password hashes and put them into a password cracker like John the Ripper. And as it turns out, we can actually do the same thing here. And if I had more time, I'd actually go through the whole process. But I'll short circuit it by saying we can use the attacker's tool against the attacker. We can crack this password using John the Ripper. And we're then able to open this file up and see exactly what data just walked out of our environment. That's your credit card numbers. That's your social security numbers. That's your sensitive intellectual property. And that's the ability of having IDS alerts, protocol metadata, full packet capture, all working together so that we as defenders can actually solve these investigations in a timely manner, and we're able to then catch those bad guys and hopefully bring them to justice. Did y'all like that case study? Pretty cool? Oh, stop. All right, so now that I've convinced you of the value of Security Onion, you're ready to play with it yourself. You're ready to take it for a test drive. So go to our website, securityonion.net, click the download link. You can download our ISO image. You can get it up and running in a virtual machine, just like I did here today. You can use that simple use case of Esso import Pcap, and you can import the Pcap file that we've included right in the distro, and you could work through this entire case study just like we did today. So once this video is released, you could go back and you could follow along at home. Of course, we do sell preloaded appliances with our free and open source software. So if you're interested in that, reach out to us at securityonionsolutions.com. And for more contact information, of course, like any good free and open source project, we do have a mailing list, and it's a quite active mailing list. So if you have any questions or problems, you can reach out to our mailing list there, and you should get a response within 24 hours. We have a very healthy, very helpful community who's more than willing to help you out with your issues. And of course, we do have professional services and appliances, so you can reach out for more information there. So do we have a couple of minutes for questions? All right. If you have a question, raise your hand, and the microphone will come to you, and you can speak your question into the microphone.
I've really got two. The first one is you use the acronym DFIR. And then the second one, are you planning to upgrade this to like Ubuntu 2004 when it comes out?
Okay, so the first question was about the acronym DFIR, so that's Digital Forensics and Incident Response, right? So that's an entire community of folks that spend their entire lives doing incident response, doing exactly what we did here, and that's monitoring networks, whether it's network traffic or endpoint data, looking for bad guys, doing the threat hunting, and ultimately responding to that. So that's DFIR, Digital Forensics and Incident Response. The second question was about, are we going to be moving to more modern versions of Ubuntu? Absolutely. So currently we're based on Ubuntu 16.04, which is a long-term support release. It's still fully supported because it is LTS. But we already are working on supporting 18.04, and of course 20.04 comes out, next month? So we'll be working to support that as well. That will be for our next generation platform that I talked about earlier, which is primarily Docker-based. And because it's container-based, that means it's a whole lot easier for us to support multiple Linux distributions, not just Ubuntu 16.04, 18.04, 20.04, but also Red Hat, CentOS, and others as well. We have time for any more questions? Yes, sir.
For the training purposes, this is such a fantastic presentation.
Thank you.
Is there an environment that can be created, multiple VMs or something like that, where for training purposes a person has to go through this and address it? So it'd be like several VMs of Windows machines and all that kind of crap. Kind of sort of capture the flag only for this. Are you aware of such a thing?
That's exactly what we do in our training classes. So the question was about a large VM environment where you have multiple hosts and different kinds of network data and things like that. And so we try to make our training as real world and as relevant as possible. And so we have a 4-day basic class, a 4-day advanced class. If you're interested in more information, you can reach out to us, and I've got business cards here as well. Other questions?
Yes, I have one. Do you have a study case for embedded Linux? That's one question. Second one is, you mentioned the VM and the Dockers. Because Dockers you can really go into as admin. Do you have concern about the security? Because I'm hesitate to use Docker, sorry.
Okay, so let me start with the second question, which was about Docker and containerization. So we've been using containers for the last few years, and we've done many steps to make sure that the way that we deploy those container images is as secure as possible. So we've gotten to the point where we feel pretty confident in using that as our deployment mechanism, and that's why our next generation platform is primarily container-based, because we do have that confidence that we've put the right steps in place to make sure that that's going to be solid and secure and reliable. The first question was about use cases, but I think I missed the second part of the first question. Embedded. So you're talking about specific Linux distributions that are aimed at embedded devices? Well, it may depend on your definition of embedded. I can tell you that we have a lot of folks that monitor operational environment, which have embedded devices in them. And on those operational environments, and let's say it's a utility company, right? They have an operational network which has lots of embedded devices connected to it. We monitor those networks the same way we would monitor a traditional office network. When it comes to deploying agents to embedded devices, that might be a little bit more difficult, but it's super simple to monitor network traffic because you're always going to be collecting that from a tap or a span port. You're not having to install an agent on that embedded device.
I think we're out of time. I just
Okay.
wanted to say I've been here for 15 or 16 years, and this talk and the talk that preceded it are two of the best talks I've ever seen at scale.
Awesome.
I want to thank you very much.
Thank you.